Hey everyone, welcome to DRX Learning Hub, your trusted platform for B.Pharm first-year lectures. Today, let me break down one of the most basic yet absolutely essential topics in pharmaceutical analysis, acid-base titration. So, what exactly is acid-base titration? It's a super common and important method used in pharma labs to check the strength, purity, and concentration of drugs, whether they're acidic or basic. The whole idea boils down to a simple neutralization reaction between, you guessed it, an acid and a base. Now, the formal definition: acid-base titration is a quantitative analytical method where we use a solution of known concentration, called the titrant, to find out the concentration of an unknown solution, or analyte, thanks to a neutralization reaction. The principle is pretty straightforward. Acid plus base gives you salt and water. The trick is knowing when this reaction is perfectly complete. For that, I rely on pH indicators or modern potentiometric methods to spot the endpoint. But not all acid-base titrations are the same. There are four main types. First up, strong acid versus strong base. This one gives a sharp endpoint. Indicators like phenolphthalein or methyl orange work great here. Next, strong acid versus weak base. Usually I prefer methyl orange. For weak acid versus strong base, phenolphthalein is the way to go. But weak acid versus weak base? That's tricky. There's no sharp endpoint, so potentiometric detection is a must. Speaking of indicators, here are the most common ones I use. Phenolphthalein changes from colorless to pink between pH 8.2 and 10. Methyl orange shifts from red to yellow in the pH range 3.1 to 4.4. And bromothymol blue goes from yellow to blue between pH 6 and 7.6. Let's quickly run through the procedure. First, I rinse and fill my burette with the standard solution, could be NaOH or HCl. Then, pipette a measured volume of the analyte into a conical flask, add 2 to 3 drops of indicator, and titrate by slowly adding the titrant, swirling constantly. As soon as the color change stays, that's my endpoint. I note the initial and final burette readings and repeat for concordant values. For calculations, I use the formula N₁V₁, N₂V₂, or M₁V₁, M₂V₂, simple and efficient. Applications? Tons. From standardizing acids and bases, drug assays, purity testing, checking water content in formulations, to quality control. Acid-base titrations are everywhere in pharmacy. Why do I love this method? It's accurate, reliable, simple, fast, and pocket-friendly. But yes, it depends on the right indicator, and weak acid versus weak base titrations can be less accurate. Plus, solutions must be clear, no turbidity allowed. So, that's a quick but solid intro to acid-base titrations for your B.Pharm journey. Like, share, and don't forget to subscribe to DRX Learning Hub. Thank you.